This is Mike Rogers, Olympian and world champion sprinter, and this is him getting strapped into a safety harness, not to jump out of a plane, but to run on a high-speed, custom-built treadmill. This is one of the fastest treadmills in the world. It's located in Dallas, Texas, inside this small white building. From the outside, you would have no idea that this is a lab that studies the fastest humans in the world using the most advanced technology available. It's called SMU Locomotor Performance, and it's led by Dr. Wayne, biomechanist and physiologist. He is the scientist that top coaches seek for information on speed development. The same coaches who train your favorite athletes. For example, when Olympic hurdler David Oliver took home bronze, his coach took him to see Dr. Wayne. He pointed out 2 fatal weak points in his running mechanics. After addressing these problems, he went on to win gold at the World Championships in Moscow. While at Harvard in the 90s, Dr. Wayne even led experiments where researchers would place animals such as cheetahs, wolverines, and even kangaroos on treadmills to understand their movement mechanics. Billionaire and NBA team owner Mark Cuban even gave his lab a $100,000 grant to fund a personal project related to basketball. And if that sounds interesting, well, that's nothing compared to what Dr. Wayne has uncovered in his work. It's safe to say that he's one of the world's leading researchers in speed science. According to Scientific American, this treadmill is worth approximately $250,000. Now you might be wondering, why is it so expensive? First, it reportedly reaches speeds of up to 90 miles per hour. The fastest speed most commercial treadmills can reach is around 12 miles per hour, which makes this one dangerous even for an elite sprinter like Mike Rogers, requiring him to be secured into a harness. Second, it has special plates that can measure the force of a runner's foot strike. These plates are similar to a scale because they measure how much force is being applied. However, unlike a scale you will use to weigh yourself in the morning, these plates are designed to measure extremely high amounts of force applied violently during a sprint. And third, it has 3 cameras positioned around the treadmill. These cameras capture ultra high-speed video and 3D images of the runner. This allows the researchers to slow down the footage much more than your iPhone or DSLR can currently do. This is the ultimate treadmill for analyzing the fastest humans in the world. This high-tech machine worth $250,000, along with Dr. Wayne's work, helps us answer the question, what is the secret to running faster? This is a graph that shows the relationship between top speed and ground contact times. In other words, an athlete's maximum speed and how much time their foot spends hitting the ground. As you can see, the faster the athlete, the less time their foot was in contact with the ground. For example, Mike Rogers had contact times around 82 milliseconds. A world-class sprinter's foot spends less than 1/10 of a second on the ground, which is faster than the blink of an eye. So does that mean that taking faster steps is the key to running faster? Well, not exactly. Essentially, speed is the product of frequency and length of a runner's steps. Prior to Dr. Wayne's work, the natural assumption was that to run faster, all we needed to do was cycle our legs faster. That assumption was shattered in September of 2000. While at Harvard, Dr. Wayne led a study to figure out what sets apart elite sprinters from everyone else. Him and his team compared 33 subjects, all with varying levels of sprinting ability. They analyzed each individual's mechanics while running at top speed, and what he found was very surprising.
The time each of you spends in the air and the time that each of you takes to pick the limb up and put it back down in front of the body for the next step is about the same. And that's true, generically speaking, from Usain Bolt to little old ladies.
At top speed, every runner takes around 1/3 of a second to pick up their foot and put it back down again. In fact, Wayne believes there's very little that we can do to increase the speed of our leg cycle, with one exception. Athletes that run on artificial legs made from carbon fiber may have an advantage. Due to the material, each leg can weigh less than half of what a natural leg would. Having such a lighter load would allow an athlete to swing their legs significantly faster than a runner without artificial limbs. But of course, this isn't a practical option for most of us. This does raise the question, if we all cycle our leg at the same speed, then how does one person run faster than another? According to Wayne, when Usain Bolt is running a blistering 27 miles per hour, he hits the ground with about 1,000 pounds of force in each step in as little as 0.04 seconds. We can think of an elite sprinter's foot strike as a punch from a professional boxer. Lightning fast, yet incredibly powerful. Let's take a look at how the power in Usain Bolt's foot strike compares to that of other athletes. During an experiment with the New York Times, 3 elite runners were invited to Locomotive Performance to run on the world's most advanced treadmill. Runner number 1, a 100-meter sprinter, runner number 2, a middle distance runner who does the 800, and runner number 3, a marathon runner who essentially does 42,195 meters for comparison's sake. Here's how much force they put into the treadmill during their foot strike. The marathoner put down 3.2 times their body weight. The 800-meter runner, 3.4 times. And the 100-meter sprinter put down a whopping 3.9. According to this chart, courtesy of Jeff Nippard, a pro bodybuilder and international powerlifter, squatting more than 3 times your body weight is something that not even elite powerlifters can do naturally, and only a tiny percent of genetic freaks will ever be able to do so. Now, this isn't meant to be a direct comparison because ultimately the mechanics are different. However, if you think that's impressive, what's even crazier is how much force Usain Bolt puts down relative to his body weight, which isn't easy given the fact that he is one of the biggest sprinters in history, standing tall at a staggering 6'5", weighing in at 207 pounds. This is about the same size as Michael Jordan. Because he has a larger mass, he needs to apply even larger forces to move fast. He strikes the ground with not 4 but 5 times his body weight. At his size, this shouldn't be possible. So then, is running faster just about putting more force into the ground? Let's break it down. The amount of force you strike the ground with relative to your body weight determines the length of your stride. Simply put, the harder you hit the surface, the further you go on each step, which explains why it takes the average Olympic sprinter about 45 steps to run the 100 meters. Meanwhile, it takes Usain Bolt only 41. Evidence shows that to run faster, the fastest human in the world does it by having a longer step length than his competitors, which is the result of not only having longer legs, but also a powerful foot strike. Now that we've established that more ground forces lead to longer steps, which leads to gold medals, we still haven't discussed how we can do this. The most important question of this video remains, what is the secret to running faster? Let's take a look at this study. Wei-Yin and his team invited 7 athletes to their lab, including an all-American track star and a dancer. They had them sprint, hop on one leg, and run backwards. What they found was completely unexpected. The one-legged hop generated much more force than sprinting did. How come? 1, you have to jump higher in order to land on the same foot. 2, in doing so, your foot spends more time in contact with the ground. In fact, during one-legged hopping, Wei-Yin found that they actually hit the surface with 30% more force. This means that in theory, athletes are physically capable of putting more force into the ground. The answer to the question of this video is contraction speed. That is, quote unquote, the secret to running faster. Wei-Yin suggests that to run incredibly fast, even faster than Usain Bolt, a sprinter must generate higher forces in less time during the limited duration that their foot is on the ground. To do so, a sprinter's muscles would need to contract ridiculously fast, more than they currently do, which is insane considering they already train for this and do contract very quickly. How can we do this? One option would be to increase the amount of type 2X ultra fast twitch muscle fibers. According to Dr. Andy Galpin, one of the world's leading researchers in muscle fibers, this is the fastest muscle fiber type present in humans and is only available in tiny amounts. Another option would be technology. As science and tech continues to evolve, there will eventually be a company that creates a surprisingly effective solution. It's already been done in other sports. For example, in swimming, the laser racer suits were banned from major competitions due to the unfair speed advantage it gave swimmers. If that sounds interesting, then you'll enjoy this video, which talks about a shoe that was almost banned from the Olympics. It was designed by Nike to be so effective and provoke such a massive reaction that the official World Athletics Organization rewrote the rules. Even Usain Bolt had something to say about it, and you can click here to watch that video.